a heap dump, right? So heap dump is, like most of you know, right? You take a heap dump, it will give you a complete view of all the objects in the heap, right? It gives you, what are the top consumers, or what are the key objects, what is the size they occupy. It also gives you who are all the other objects that reference them, right? The good thing about heap dump here is, right, a garbage collection is forced before a dump. Now, if you have a heap of 1.4, you take a dump, right? It will force a GC just before taking a dump because it will clean all objects so that your heap dump only has objects for your interest, right? Objects that are still referenced and somehow not cleaned by garbage collection, right? So heap dumps used to be your classic text view. The problem with heap dump being that is, if you're running a 1.5 GB heap and you take a heap dump, the size of the file will be 1.4, 1.3 GB, right? To copy it to your tool in your Windows machine, right, it's going to be very, very tricky. So that's why we have portable heap dumps, right? Portable heap dumps is a compact heap dump, right? So when your heap is 1.2 GB, when you take a PhD or a portable heap dump, it will still be about 200, 300 MB. So you can easily copy it over to your local box and use tools like ISA heap analyzer to analyze them, right? So if you look at ISA, right, once you load a PhD heap dump, it gives you information in, it will help you identify memory if there are any memory leaks. It will help you identify what are your key contributors to heap. So one example is, right, when we used to take heap dumps earlier, we used to always run into that the cache objects are very, occupy like 300, 400, 500 MB in heap, right? Something that you don't want. So that's why an in-memory grid or a centralized or an external grid is helpful, because that heap size is completely removed from being used. So if you take, heap dumps are taken typically during load tests, etc. When the application is very hot, running very high heat, take a good heap dump and look at what are the objects, right? You should be able to tell you, what are all the objects that are very highly used and not getting released properly. So the next one is talking about from heap dump is garbage collection, right? GC, like I was telling that the garbage collection policy that we typically use is GenCon, which has a tenured area, and it has separate garbage collection cycles for nursery and tenured areas, right? So if nursery is 350 MB, it will keep collecting it very often so that your short-lived objects are being flushed out very, very frequently, and then only your tenured, your major collection or your tenured area collection is less frequent, right? So I've listed a lot of metrics here, which will help help find out, right, heap characteristics or GC characteristics, right? I think the core problem is this, right? Looking at the GC, you should be able to find out if you are going to trend to an out-of-memory exception, if you are going to see fragmentation, if there are any pauses. So look at the three graphs in the page, right? So here's a good in the first graph, right? You could see that the red line, which is your free space after your garbage collection, gradually coming down. So this is one. When you run out, when you have memory leaks, you will not see it immediately. It will slowly come down and eventually just crash, right? And to your right side, right, you have another graph where the red line is nothing but your free, basically your allocation, spaces, right? So this number obviously will be smaller because you're talking purely about allocation failure. But this is a case where you will run into this fragmentation, right? Because what is happening is you're not having contiguous blocks basically, available for an object to be allocated. And the last one, this one is a nice looking heap dump or a nice looking GC, very, very healthy. You have enough, when you have GCs running regularly and heap being freed up. So that's about memory profiling. The last topic, quick 2 minutes, is about thread dumps. It's very, very common to run into a stage where a JVM is slow, right? Or you do not know why is it slow, but it is slow, right? It could be because of dead loss, database, network contention, anything. that's where Java codes help. You take few Java codes in a period of 30 seconds, and you will get a good view of what is causing the issue, right? So typically, right, when a Java code is taken, it will give you information as what are each of the 30 or 40 web container threads doing? Are they waiting? Are they in a running state? Are they waiting on some other thread? Is there a deadlock? All those features, all those information will be taken through a Java code. So the best practice is, if you run into an issue of Java, JVM being slow, take 2 to 3 thread dumps in 30-second interval, and then compare the thread IDs, right? So it looks something like this. So if you see this graph or this picture, I've loaded a thread dump in ISA. So there are a lot of these web container threads here, right? So I've selected one of them, and it clearly says that all threads are, so I've selected one thread here, and it says that this thread is holding up like, almost 15 threads. So then you know that there is a bottleneck. Then you go and find out what that thread is doing, and then it will tell you that it is holding a lock on some other object, right? So that's how you kind of narrow down, what happens in a thread dump. So I just want to finally summarize one slide on key takeaways, right? Site performance is extremely critical. I would say it's the biggest cross-cutting concern in any e-commerce application. We need to approach performance tuning in a very tiered fashion. Every tier is important, and it's not just your code or design. The third is caching. Leverage is probably your single biggest lever to achieve high performance. The fourth is watch out when you customize WCS. Well, out-of-the-box frameworks will offer good performance. If you make terrible, customization decisions, it will actually kind of kill your performance. And then the last is, right, code profiling, heap dumps, thread dumps, and GC logs are really the best way to measure performance and improvements. So, with that, right, I just want to pause here. We've covered a lot of, topics. Like I said, right, treat this as a 101 because there are, you can talk about these topics for a long, long time. So with that, I want to just jump to, come to the end of the webinar and see if there are any questions from the group.